Hello everyone and welcome to our channel Mootechie. It's a pleasure to have you with us today as we dive into the fascinating and practical world of woodworking. We'll be exploring all the essential tools, learning what they're for and how they're used, so you can feel more confident in your own workshop adventures. So let's get started and uncover the craft behind the wood. Now let's begin by looking at the different types of tools used in carpentry. The main categories are marking and measuring tools, cutting tools, planing tools, boring tools, striking tools, holding and supporting tools, and finally, miscellaneous tools. Moving on, we come to our first major category, marking and measuring tools. These are the tools that ensure every cut and joint is precise. They include the carpenter's folding rule, the straight edge, the tri-square, and various gauges like the marking gauge, mortise gauge, and cutting gauge. Let's understand this more clearly. First, the carpenter's folding rule. This is a wooden scale used for measuring and setting out dimensions. It consists of 4 pieces, each 15 centimeters long, hinged at the ends so it can fold up. When you open it out completely, its total length is 60 centimeters. Next, the straight edge. This is a machined flat piece of wood or metal. Its main job is to test the trueness of surfaces, to make sure they are perfectly flat and level. Now the tri-square. This versatile tool is used for a variety of purposes like measuring and setting out dimensions, testing flatness, drawing parallel lines at right angles to a plane surface, and checking the squareness of 2 adjacent surfaces. A tri-square consists of a steel blade attached to a wooden or cast iron stock. Sizes vary from 150 to 300 mm according to the length of the blade, and the blade is often graduated to serve as a scale. Coming up, we'll discuss gauges. Gauges are very important carpentry tools used for marking and for cutting. A gauge essentially consists of a small square or rectangular wooden stem that slides through a wooden stock. The stem carries one or more steel marking points or a cutting knife. To use it, you hold the stock firmly against a plane surface and push the whole tool along to get the required markings. Let's look at a diagram labeled Figure 1. It shows the parts of a typical gauge. We see the stock, which is the main body you hold. The stem slides through it. At the end of the stem is the adjustable spur, which is the marking point. A set screw and a nut are used to lock the stem in place at the desired measurement. This leads us to the different types of gauges. The marking gauge has one marking point. It gives an accurate cut line parallel to a true edge, usually along the grain. The mortise gauge has 2 marking points. One is fixed near the end of the stem and the other is attached to a sliding bar. These 2 teeth cut 2 parallel lines, called mortise lines, which are needed for making joints. Then there's the cutting gauge. It's similar to a marking gauge, but instead of a marking pin, it has a steel cutting knife held in position by a wedge. This wedge enables the depth of cut to be varied. This gauge is used for cutting parallel strips of thin wood sheets up to 3 mm thick, for gauging fine deep lines, and for cutting small rebates. So to summarize, we have the marking gauge, the mortise gauge, and the cutting gauge. Following this, we have an image specifically of a cutting gauge. It shows the tool with its distinctive cutting knife instead of a pin, ready to make a precise slice in the wood. Now let's move on to a fundamental group, cutting tools. This category includes saws, chisels, and the axe. All the saws used in woodworking consist of 2 main parts, the blade and the handle. The blade, made of steel, carries the cutting teeth. The handle, made of wood, is for holding and applying pressure. The teeth of the saw are given a set, meaning they are bent alternately to the left and right. This creates a wider cut than the blade itself, which prevents the saw from binding or getting stuck during the sawing operation. Saws are classified as push-cut saws or pull-cut saws, depending on whether they cut on the forward stroke or the return stroke. Push-cut saws are more common. Saws are generally specified by the length of the blade measured along the toothed edge and the pitch of the teeth, expressed in millimeters. Let's break down the different saws. The rip saw is used for cutting along the grains in thick wood. Its blade is about 120 to 200 mm wide near the handle, and tapers to about 60 to 100 mm near the tip. The cutting action starts from near the tip and gradually involves the whole length. The blade is about 700 mm long with a tooth pitch of 5 to 8 mm. Next, the hand saw, also known as a cross-cut saw. It's designed primarily for cutting across the grains, but is often used as a general-purpose saw. Its blade is 500 to 700 mm long. A blade with a finer pitch is preferred for hardwoods and a coarser pitch for softwoods. While it can be used for cutting along the grains, it's slower than a rip saw for that task. Then we have the compass saw. Its blade is quite flexible, which allows it to easily make straight or curved cuts on the inside or outside surfaces of a workpiece. We see two images here. One is of a crosscut saw, showing its typical design. The other is of a compass saw, showing its narrow, tapering blade that's perfect for intricate cuts. Now the tenon or back saw. This is more commonly used for cross-cutting when a finer and more accurate finish is required. The blade is very thin, so it's reinforced with a rigid steel back along the top edge. Blades are 250 to 400 mm long and are very fine, with about 13 teeth per 25 mm. An illustration shows the parts of a tenon saw. We see the thin blade, the sturdy brass back that gives it rigidity, and the handle. Moving forward, let's understand chisels. Chisels have forged steel blades fitted into wooden handles and are specified by the shape and width of the blade. The firmer chisel has a flat blade about 100 to 150 mm long and 3 to 5 mm thick. It's the most general-purpose chisel, used with either hand pressure or a mallet, depending on how much material needs to be removed. Widths vary from 3 to 50 mm. The beveled edge firmer chisel, also known as a dovetail chisel, has edges that are beveled. This beveling reduces the thickness of the chisel at the sides, allowing it to enter sharp corners and finish them beautifully. It's used for fine and delicate work. The paring chisel is essentially a firmer or beveled edge chisel, but with a long, thin blade. These chisels are generally manipulated by hand alone for precise paring cuts. They are 5 to 50 mm wide and 225 to 500 mm long. Finally, the Mootechie chisel. This heavy-duty chisel is used for taking heavy and deep cuts, like when making mortises. It has a heavy blade with a generous shoulder or collar to withstand the forceful blows of a mallet. Blades vary in width from 3 to 16 mm and are very thick, from 6 to 15 mm. A diagram shows the different types of chisels. We see the handle, the metal ferrule that reinforces it, and the blade. The four types are labeled A. Firmer, B. Beveled edge firmer, C. Paring, and D. Mortise, each with a distinct blade profile. As we continue, we come to planing tools. These are used to smooth and shape wood surfaces. The main ones we'll cover are the wooden jack plane and the metal jack plane. Other important planes include the trying plane, used for finishing with a very fine cut, the smoothing plane, which is small and used for final smoothing and finishing, the rebate plane, for making a recess along the edge of a wood piece, and the plow plane for making small grooves where panel fitting is required. Let's look at the wooden jack plane in more detail. This is the first plane used on timber to true it, meaning to make it flat and straight. It consists of a block of wood, called the stock or body, into which the blade is fixed with a wooden wedge. The bottom face, called the sole, is made perfectly smooth and level. The blade, made of high-carbon steel, is fixed at a 45-degree angle to the sole and is held in place by a tapered wooden wedge. Another blade, called the capiron, is fixed on top of the cutting blade. It doesn't do any cutting itself, but it supports the cutting blade to prevent chattering and helps break the shavings, making them curl away from the work. Jack planes are 350 to 425 mm long, with blades 50 to 75 mm wide. An image of wooden jack planes clearly shows all the parts: the blade, the capiron, the wedge, the handle, the main body, and the sole. Now the metal jack plane. It serves the same purpose as the wooden jack plane, but facilitates a smoother operation and gives a better finish. The body is a grey iron casting, with the sides and sole machined and ground to a bright smooth finish. The thickness of the shaving is controlled by a fine screw adjustment, and a lateral adjustment lever is used to make sure the blade is perfectly square to the sole. Next, we explore boring tools, used for drilling holes. The spring bit is used for drilling holes not larger than 5 mm in diameter. It can be driven in by a hammer or with an oscillatory hand motion, and it's chiefly used for making pilot holes for large nails or screws. The brace is a tool used for holding and turning bits to bore holes. It can be a ratchet type or a wheel brace type. The auger is a long steel bar with a fluted body for about half of its length and an eye at the top for a handle. A small screw at the bottom acts as a pilot to start the hole. You operate it by holding the handle in both hands, rotating while pressing down. Augers are used for rough structural work and come in sizes up to 25 mm diameter. A gimlet is a smaller form of an auger, used for producing small holes and operated in the same way. An auger bit is a small auger designed for use with a brace. It has a screw point and a helical or twisted stem, and it produces long, clean and accurate holes from 6 to 35 mm in diameter, either along or across the grains. Finally, the countersink bit. This bit is used for making conical depressions to recess screw heads flush with the surface. It's also known as a rose bit. Let's look at an illustration. It shows a gimlet with its simple twist design and a countersink bit showing its conical cutting head. Another diagram provides a detailed look at an auger bit. It labels the different parts: the shank that goes into the brace, the twist or flute that carries the chips out, the cutting lip that does the actual cutting, and the feed screw at the very tip that pulls the bit into the wood. The shank diameter is shown in a range from 10 mm down to 3 mm. Moving on, we have striking tools. These are the mallet and the hammer. The mallet is a small wooden hammer with a round or rectangular cross-section made of hardwood. It's used to give light, controlled blows to the handles of cutting tools like chisels and gouges. Now hammers. Two types are commonly used in woodworking. The cross-peen hammer is used for light bench work. It has a cast steel head with a tempered face and peen, and a wooden or bamboo handle. The claw hammer is a real multitasker. In addition to being used for driving nails, its claw can be used for pulling out bent nails, which makes it a favorite among woodworkers. An image shows a claw hammer, highlighting its distinctive curved claw. Let us now look at holding and supporting tools. These are essential for securing your work. The workbench is the foundation. On it you often find a bench vise. Other important tools include the bench stop, which is simply a block of wood projecting above the bench top to prevent wood from sliding forward during planing. Then there's the bar cramp. Finally, cramps and screws of various types, like the common C-clamp and hand screw, are used for holding odd-shaped workpieces. Coming up, we have our final category, miscellaneous tools. This includes rasps and files, which are used for cleaning and shaping curved surfaces. The pincher, which is used for pulling out nails, tacks, and other small fasteners. And finally, screwdrivers. They are used for screwing or unscrewing screws used in wood. Screwdrivers for carpentry work typically have long handles and a strong durable tip to apply good torque. And that brings us to the end of our tour through woodworking tools and their uses. We've covered everything from measuring your first line to driving your last screw. It's amazing how the right tool can make all the difference in bringing a piece of wood to life. Thank you for joining us on this journey into the heart of craftsmanship. Thank you. See you in the next class.